Okay, so welcome back. So we are going to continue our chapter 19 discussion about Java collection framework. And this example is about map. Okay, so keep that in mind. Map is about a key value pair. So not like previously, it's just about a single object like the book. Okay. And here we are going to use the collection hash map, linked hash map, navigable, and we are also going to use that tree map. Okay, so the interfaces and with the classes. So we need to import them. And then, so as usual, the first, what we do is we have a map object. Okay, created using hash map. And be careful for that, it's a key value. So that's why the generic type, it indicates this is a key and this is a value. Okay, so key is integer and value is a book. Okay, we create 8 books and then we add the book to the map. Okay, because it's key value pair. So that's why you need to specify the key and the value. When you add a new item, you need to specify key. And then we can also output of the map, the data structure, and it has a for each method itself. So you can just directly go ahead and call this for each method. Then we output, and be careful here, we have both key and value pair. So that's why. And then we can also check if the key is the book ID, okay? And this is you have key and you want to get the value, okay? And for this, it contains value. You can check if it contains certain book using it can not just a key, you can do search, you can also search value, okay? And for this one, it's sometimes also quite useful as you try to search some item like here. If it doesn't exist, then it will use this default one. Default one. Okay, so this is so get or default. So if it doesn't exist, then you use default. If it exists, then it use its own. You can also get the complete key, and it's a set. Okay, so that's why you start in a set. Then you can also get off the value. The value here is we start in a collection. Okay. Well, we can take a quick look of the output. So what we do is, yeah, so here, did you see it has a key and value? So key and value use a colon to separate. The book itself, of course, has the ID, okay? And then to check the key, okay? And the book with it gave you the value, okay? So it gave you value. And there to try to use a value to find, to do search, okay? And this is a default one, that use the default. And it retrieve all the keys, retrieve all the values, and then what next we can do here? Let's see what we do here. Yeah, let's move on. For the next, we have this compute method. Okay, so what the compute method is try to do is it try to use the key, is it? And with the key, try to find the item, it's going to update the value part. So the 115, is it 115? Previously is this item. We try to update it to this one, okay? And we can see, yeah, it does update it. So if you, it also allows you to do update, and here you can do is you can take advantage of this lambda expression, okay, let's compute, okay. And you specify key, and then this is a key value part, okay. And then you do the respective operation. And this compute if absent, okay. This can also, so put, if you recall, put can be used to add new item, okay. And the compute can also be used. You can use it if absent, to check if the key exists. And we can see the key doesn't exist. If it doesn't exist at all, we can add a new item. Yeah, so do you see the new item does get added? Okay. And then you can also use this merge. Okay. Merge, then check, okay, if the key, because sometimes you add a new item, so is it already in the map? Is it, yeah, if it's already exists, then you can update with this item's new value. If you recall previously, this is A, B, C, D. Yeah. Now we want to update it, okay? Yeah. If it is not, it will just go directly with this case. And we can see it's not this case because it's already exists. Then you update the old value using this new value to do the update, okay? And we can also see for the key 117, you can see it doesn't exist. Is it doesn't exist, then we can just go ahead directly add this new item. Yeah, it's added. So that's, so it will not use the other case. Okay. So that's this part quite useful, you can see. Yeah, very powerful for the math. And what next we did is we tried also this compute merge. And what next we move to is we try to get all of the map entries. Okay, so we don't call it item, we call it entry. Okay, entry set. You can collect it, so you can store it in a set. Okay, and the set type, so be careful, it's a little bit complicated. Some map, the entry, it has a key value. Okay, now after that, we can also using the for each loop. Okay, but be careful the type. Okay, and then to use get the key and get the item. Okay, and yeah, so here is the output of the whole map entries after updating. Okay. Okay, so that's how we take advantage of this entry set. And then next, let's see. Next, what we created a tree map object, and the type is navigable map. So we try to also do some traversing because for sorted map, it only supports sorting. And we add all the item using the previous map, okay? And we can output it. And if you take a close look, you will find that it's sorted. It's sorted, okay? And for tree map, we can also create a reversed order for the tree map. There is a nice way to do that. Here for this tree map 2, we use the tree map. What we do is, did you see we create the the order that we create the order with the reversed order. So that's how we do that. Then you add it. So here is just introduce a second way if you want to do the reverse way. We don't need to do one by one. Okay, you just yeah get we just specify okay from the previous the key order we try to reverse it. Okay, then it's going to be reordered in descending order, basically. And then this is our original tree map. You try to get first entry and last entry. You can see it does following the order, is it? And we can also see based on key, is it you can also find, okay, the lowest key that greater than, so that's the right part. Is it the lowest greater than? Yeah, we don't have key 120, is it? So, okay. And the lowest key greater than 120, and so here you also get its entry, is it? So yeah, so this will give you, so not just the key, it will also you can get to the entry. So same thing for floor, for the top one. So that's this case. You can also get it using the floor and the floor entry. Okay. So similar, you can do higher and higher and we can also get a head, tail, and you can also get the subset. Okay. So similar concept. Mm. You can see the output is it, and here we have the floor, and then we also have the hierarchy is a key greater than 120 is 121 here to specify, okay, and the key greater and its map, yeah, it gives you, is it? Yeah. And so over here, we remove some key. Okay, 117. It's should be removed. Okay. And after remove, we want to check if it is still there. And then we do the descending order. So let's take a look. The output. Yeah, you can see. After you remove it, then descending order. Yeah, that's arranging descending order. Okay. And let's see. For this one, yeah, similar, we can also call string, but what we do is here, we use the entry set first, okay? And after that, you can do the filtering based on key. And after that, we try to collect all the values, and then we output all of that, okay? So the stream method, yeah, is the output of the, so you can do filtering, okay, quite useful. And what next we do is, so all these above is the tree map, okay, so it supports the sorting for tree map. And what next is a hash map. It's a linked hash map. And the hash map, the advantage is quick lookup. Lookup, okay, so it's order of one time complexity, okay. And we do one by one fill, okay, using the book collection. And after that, you can also uh, output of the key and value pair. And see the output. Yeah, here is a linked hash map. Okay, it does provide that. And then lastly, let's see what we did here. And here we create another linked hash map. Okay, the capacity to only allow 20 items, okay, 20 entries. And we use that array to do one by one adding. And then we try to see. So for the linked hash map, there is a specialty for it is the map order can be updated with its following the access order called least recently accessed to most recently accessed. Okay, because you see here we try to access the 211. Is it that key item? Okay, and we saw access here. Accessed here. Okay, so the order it can be updated from least recently accessed to most recent. So most recently is this item. Is it? So let's see. If you take a look, the 221 is it previously is here. Okay, the second last. After we call the access, after we call the get, so it access, so it's moved to the last. So it's being moved to from the following the access orders least recently accessed to most recently accessed. Yeah, we can see it does. So it is moved to the end of this entry. Yeah. Okay, so that's about this example. We are going to come back in a short while for the next example.